So we're basically just continuing from yesterday, as I was saying. And what I'm about to do is put all the points in from the red line into my table. And although we already did the reflection on the y-axis, I still want to put my points in based on how we know the rule is for reflections, which is to change on a y-axis, is to change your x values, their sign. Okay? So let's put those points in now. Let's start by let's start by putting in our y values, or sorry, our x and y values. So 1 minus 3 is one value right there, 1 minus 3. What would be the other points on this graph? If we were using the step pattern, across one, up one, what would be my next point? What was the second point that we use here and the point on the other side? What's that point right there? Right, just a coordinate. What is that coordinate? Anybody? Yes, go ahead. AJ, what's that? 2, negative 2. Good. If everybody agrees with that. What about the point on the other side of that? What about that point on the left of that? What point is that? Anybody? What are the coordinates of that next point? I'm just using step pattern here. Yes. 0, negative 0, negative 2. Good. And the truth is, we can actually continue using the step pattern from here. Remember, we're going across one and up one. So we're going from 1 to 2. So we're going, if you think about it, we're going 1 along the x, which is 1 more, which takes us to 2. If we go 1 left, it's going to take us to 0. So let's keep going with the starting at 1. We went across 1. Let's go across another 1, which would take us across to what? From 1. We're starting at 1. We went across 1, so we went to 2. So the next one would obviously be 3. You're just adding 1. Right? Whoa. What is going on? So this is 0, and this is 3. I don't know why it's doing that. Okay. But what about and by the way, let's do it on the other side. We went to 1, right? And then we went left from 1, we'd go to 0. If we went left again from there, we'd go to what? Let's just keep going left. Yes. Negative 1. Let's just put all the x's in first. Okay, so we went from 1, went across 1 to 2, across 1 to 3. Obviously, the next one would be 4. But let's go left now. So from 1, we went to the left one, which is 0, to the left one, which is minus 1, to the left one, which would be what? Minus 2, though. Right, minus 2. But let's talk about the y's now. When we did from minus 3, we went up. Okay, remember now, you're going up. So we went from minus 3 to minus 2, and then but it's the same on both sides, just so you know, right? So the next one after that, remember now, we're going across 1 and up 1, but then we go across 1 and up 3. So from minus 2, if we went up 3 from there, that would be what? And by the way, we can read this off the graph too. You don't have to do it the way I'm doing it. No. Let's go up 3 from minus 2, which takes us up to 1. To what? If I add 3 onto that, would be what? Onto minus 2? Yeah, it gives you what? Gives you, no. You're adding 3 onto minus 2. So minus 2 plus 3 then. Minus 2 plus 3. 1. Come on. And I hope you're not going to take a calculator out for this either. I'd be very disappointed if you did that. Okay? And again, you can read all of these things off on the actual graph itself. If you think about it, it should be the same on the other side of that. But you can look at the graph and see at minus 1, you're at 1 as well. Right? Because as you go up the y-axis, you're going to be the same distance, so you're going to be on the same level with the y. But read it off the graph if you're not sure, right? And then from the 1 now, we're going to up by how many again? Step pattern says 1, then 3, then 5. So let's add 5 onto the last one that we had, which was 1. So that should take us up to 6, okay? And you can check your graph and make sure that all of that squares with what you have there. So minus 2, 6, all those points. You don't have to do it that way. You could have just read it from the graph. You could have done that as well, right? Okay, so far so good? Okay. So those are the points from the original graph. Remind me now how we are going to adjust that for the reflection on the y-axis. How do we make this work for the reflection on the y-axis? That's my question for you. Okay? Yes, Shami. Exchange sign. There you go. As easy as that. Thank you very much. You guys can give me a little room here, please. Right? I really think you're trying to trip me up. All right? You really want to see the teacher just take a face plant in this room. No, that's not going to happen. So exactly what Charmaine just said, we're going to just simply change our x values. We're trying to reflect on the y. All the x values change sign. So 1 becomes minus 1, 2 becomes minus 2, 0 cannot be changed. It's just going to be 0. 3 becomes minus 3, minus 1 becomes positive 1, 4 becomes minus 4, and minus 2 becomes positive 2. They change sign. What happens to the y values? Nothing. Minus 3, minus 2, minus 2, 1, 1, 6, and 6. Now, we should check and make sure these points match up. Right? Do they actually match up with what we said the graph would look like? We shifted everything to the left by, not shifted everything to the left, sorry. We did a reflection on the y-axis, right? So let's see if everything matches up with the graph. Minus 1, minus 3, that's that point. That's that point right there. Minus 2, minus 2, that's that point right there. 0, minus 2. I kind of missed that one a little bit. Minus 3, 1 is certainly there. Let's see, 1, 1. 1, 1. 1, 1 is not there. I made a mistake somewhere. 1, 1. 1, 1 is here. I'm looking at the wrong side. Yeah, 1, 1 is there. And minus 4, 6 is right there. And 2, 6 is right there. So it's all there. Okay, we're good. All right, hopefully that makes sense. Let's move on. Last one. Let's try the same strategy again. We're going to graph this. We're going to graph this on the same grid. So here's my original function. That's my original. Here's my transform function. What do you think is going to happen? Right? What do you think is happening if I put a minus here and a minus there? What is going to happen in this case? Yes, Jay? Say it again. Reflection on the x-axis. Is that the whole story? Is that the whole story? Yes. There's also reflection on the y-axis. Think about it. This negative here, that's just in front of the x, does reflect it on the y. The negative that was in front of the whole function also reflects it on the x. So there are two reflections going on here, is basically what we're saying. So what does that look like? Well, let's find out. We're going to go ahead and we're going to plot some points on our graph based on step pattern again, right? So my first point would be where? Where is my first point on this grid? All right, remember we have it in what we call vertex form, so that should make it easier. Yes, Yash? Negative 3, negative 4. Well done. Thanks, Gary, for offering. Negative 3, negative 4 is somewhere around, let's put this in a different color. Negative 3, negative 4 is somewhere around here. Okay, put that on your graphs for me, please. Everybody have negative 3, negative 4 there? Perfect. Now, how does our graph get developed from there? Where do we go again to develop the points on the graph? If we have the vertex, how does that work again? Yes, Abel. Okay, so from there, we're going to go across one and up one, right? On both sides. Good. Okay. So across one and up one, across one and up one, across one and up, we said 3, right? So that should take us right here. Across one and up 3 right there. And then we're going to go across one and up 5, right? So across one and up 5 take us about there. And I think we're out of real estate. I don't think we can go any further than that. Okay? Because the next one that we have to do is across 1 and up 7, and that's not possible for where we are. All right? So go ahead and draw that in. And this time, before Chase says, I'm going to put my arrows on each end, because I should. So the points that I have on here are -3, -4. And you could just read from the graph. You literally could just read them from the graph. Okay? If you're not sure how to develop it by adding 1 to this and adding 1 to that, then just look at the graph and get your points, right? This point seems to be over here. I'm going towards the left now. This point over here, in fact, you do it. Fill in your chart, fill in your coordinates, right? You can use your own graph, which is sitting right there in front of you. Put in your coordinates. Put in your own coordinates. I see some of you have done that already. Right? You can tell exactly where the coordinates are by just looking at the graph. So I see most of you have those points on the graph. All right? So I'll put mine in as well. So this looks like -4, -3. And then we have -5, 0. And then we have -6, 5, I think. And then on the other side of that, we have -2, -3. And then we have -1, 0. And then we have 0, 5. I'm assuming you all got the same thing. Okay. So we have our points. Did I miss something wrong? Did I get something wrong? No, okay. So we have our points. I want to reflect it on the X and on the Y. So tell me how that's going to work now. So Cherry, go ahead. Yeah. That's a very good question. That's a very good question. It does not. Okay? It does not matter for, there is going to come a time when we talk about the order in which you do transformations. But if you're doing a reflection and you have to do it on the X and on the Y, doesn't matter which one comes first. Okay? Are listening back there, I'm assuming, or are we texting? Which one are we doing right now? Which one is the focus now? Okay. All right. So what do we do? How do we make this magic happen? Let me go in the front. Manahill, talk to me. Change the sign of both the X's and the Y's. And then we're going to plot it and see what that looks like. What does it look like if I take a reflection in both axes? Right? I'm going to reflect across the Y and reflect across the X. And the question I just got from Suchir is an excellent question. Is it going to make a difference whether I do it the other way first? Answer the question is no. It doesn't make a difference. You end up with the same graph. So I'm going to go ahead and basically change all my signs. Every sign gets the opposite sign. Instead of -3, -4, it becomes 3, 4. -4, -3, it becomes 4, 3. -5, 0 becomes 5, 0. -6, 5 becomes +6 -5. I'm just changing all my signs. 2, 3, 1, 0, and 0, -5. You plot your graph and then ask yourself, is this what I expected? Is this where I expected it to go? Right? Does it look like I flipped it on the X and then flipped it on the Y? Does it look that way to you? All right, that's the question I want you to ask as you do this. Is this where I expected it to end up? Is this what I expected it to look like? Okay, I'll put my graph in as well. No, actually, I'm going to wait till some of you get your graphs in first before you see mine. So I'll go ahead and put my graph in now. Using a different color, I use green. So 3, 4. 3, 4 is somewhere around here. 1, 2, 3, 4. 4, 3 is somewhere around here. Here. 5, 0. And 6 minus 5. And 0 minus 5. Okay, kind of missed one of the points on the side there. Sorry. But most of you seem to have got that. And I would have to say, I know Wanya is a little skeptical, and that's legit, that's valid. I'd have to say it kind of is, right? Because here's what's happening, Wanya, is I'm taking this thing and I'm turning it upside down first, right? And then after I turn it upside down, I flip it over onto this side. You see what I'm saying? But you might say, okay, what if I had flipped it over first? It would have been over here, but then I could turn it upside down afterwards, and it would still look the same. Okay? It is going to be something that you will later learn is similar to a rotation, but we'll talk about that another time. Okay. So that's it for 2.4. All right, so remember now, when you are reflecting on the x, the y's change your sign. When you are reflecting on the y, the x's change your sign. But you can reflect on both at the same time, as we just did. All right. All right, folks. New style. Here we go. So we've transformed in two ways, either by translation, moving it left, right, up, down, or by reflection across the x, across the y. And we're going to stretch stuff. It says a vertical stretch is where the entire function is multiplied by some factor of a. That's a vertical stretch, the whole function, not just a piece of the whole function. When a is greater than 1, it's a stretch. When a is less than 1 but greater than 0, we call it a compression. So you're going to graph with me now, the x squared line, the 2x squared line, and the half x squared line on the same grid. We're going to see if there's any invariant points. We're going to describe the transformations, and we're going to talk about how we make those transformations happen. So I gave you the first table of values for y equals x squared. Right? So minus 3, 9, minus 2, 4. That's just your typical y equals x squared line. We're going to now do the 2x squared line. The 2x squared line represents a function x squared that's been multiplied by 2, which means that we have a vertical stretch. That's what they're saying here, a vertical stretch by a factor of 2. And I'll tell you how that affects your table values in a second, but let's write that down first. There's some abbreviations that you're allowed to use, because those are the abbreviations that I use. So if I use those abbreviations, you're welcome to use them as well. So I'm going to call this a VS. We're talking about VT and HT. I'm going to call this a VS BAFO by a factor of 2. So you're welcome to use that abbreviation rather than writing the whole word out. Vertical stretch by a factor of, no, just VS BAFO. That's fine. I'll understand that. Okay. Now, what does that do to your table? Well, if it's vertical, think back to when we're doing vertical translations. Which one do you think it's going to affect? Is it going to be the x or is it going to be the y? What do you think? Yes. I agree. And what that means is that we're going to leave those x values exactly as they are. I'm just going to repeat them. So minus 3, minus 2, minus 1, 0, 1, 2, and 3. Just put them back. Yes. Good question. By a factor of. I'll put that on the top here. By a factor of. It's just a short form. That's a F, not a T. By a factor of. BAFO. Or you could just write it out if you want to every time we're doing this. I personally think it's much easier just to write BAFO. All right, so what do you think happens to each of the Y's? If you had to guess, yes, Triash. They change sign? No. What do you think? That's exactly right. It's times them by 2. So we're going to take each Y value, multiply it by 2. So that's 18, 8, 2, still 0, 2, 8, and 18. Yes? Does it eliminate the negative? The negative is still there. No, it's positive 18. You're just multiplying each of the Y values by 2. Because remember, you're squaring the minus, which makes it become positive. Then you're multiplying by 2. Good question. So we're going to go ahead and draw the new graph, which represents 2x squared. And we're going to draw half x squared after that. This is a vertical stretch by a factor of 2. Every single x value stays the same. Every single y value is being stretched, is being expanded. Sometimes people call it vertical expansion. I've heard that term used before. Apart from vertical stretching, the vertical expansion, same thing. So let's go ahead and draw that function right now. So 0, 0 is on the line. I put mine in red. You don't have to use red. You may not have red. Minus 2, 8. Should be somewhere around here and here. Minus, what am I doing? Minus 2, 8. Minus, 0, 0, we got that. Minus 1, 2. I didn't put that one in. Minus 1, 2. Minus 2, 8. Put that one in. And 3, 18. By the way, if we were using step pattern, what would the step pattern be? Anybody? What's the step pattern for this? There's a step pattern here. But what is that step pattern? Yes, Jay. So instead of 1, 3, 5, you'd have 2, 6, 10. There you go. And you could count this for yourself. This is 2, 6, 10 right now. Right? You can count these for yourself. Across 1 up 2, across 1 up 6, across 1 up 10. That's exactly what this is. So that represents your stretched y equals x squared function by a factor of 2. Very slim, very narrow, compared to the original function. In fact, I'm going to go ahead and draw the original function in as well to compare the two. So I'm going to put that in a different color. I'll use purple for that. So 0, 0 is still on that line. Across 1, up 1, across 1, up 1. And then we have minus 2, 4. Minus 2, 4 should be about here. And then we have 3, 9. Should be about here. So it's actually not as slim as the y equals 2x squared line. Put my arrows on before Che catches me with that. Okay. 3, 9, right there. Okay. What about y equals a half x squared? Well, first of all, let's describe that. Would that be another vertical stretch, you think? If I were to say y equals a half x squared? Manhil, what do you think? It's a vertical compression, that's right. Because the A is now between 0 and 1. So it's a vertical compression, BAFO, by a factor of a half. So VC by a factor of a half. That's what we have. Yes?
Which one is the red one?
The red one is the y equals 2x squared, yes. Yeah. I should probably stick with the color coding that I'm using. Anyway. All right, so what do you think the coordinates are going to be? what happens to my x and what happens to my y. It's a vertical compression. All right, I see only the same hand I saw the last time. Let me hear what AJ thanks offering. Yes, AJ, what do you think? Times what by 0.5? X's or Y's? The Y's. X's don't change. Thank you. Thank you, AJ. So all my X's are still where they were. I'll use maybe what, yellow this time? I don't know. So -3. You can't read that, can you? No, you can hardly read that. So we'll stop that. We'll put green. So -3 is still -3. -2 is still -2. -1, 0, 1, 2, 3. My x values are all the same. My y values just got chopped in half. Okay? Every y value is now half what it was. Not the transformed one, but the original y's are what we're talking about. So I'm going to go ahead and say that the first one is 4.5. And then we have 2. Then we have 0.5. Then we still have 0. Then we now have 0.5. Then we have 2. Then we have 4.5. I'm going to go ahead and draw that one as well on the same grid. And I need you to do the same thing, by the way, as I'm doing it. All right? Now, what do you suspect it's going to look like compared to the ones that are there now? Is it going to be fatter, slimmer? What do you think? Yes, Gary? It's going to be wider. That's correct. That's exactly right. So let's go ahead and put that in. So -3, 4.5, somewhere around here, maybe. -2, -2. So, sorry, -2, 2. Somewhere around there. 0, 0. 1, 0.5. About there. And 3, 4.5. Okay, so as you can see on mine, and should be on yours. And folks, I'm expecting you to do a much better job than me. I'm no artist. Okay, give me a straight line, I can't even draw. Sorry, give me a rule, I can't even draw a straight line. So I'm no artist. I'm expecting you to do a better job than I'm doing right now. Hand was up over there. Sorry, whose hand was that? Somebody had their hand up. Yes. You were what? Sorry. You're just guessing. Okay. Yeah. Unfortunately, when I'm photocopying, it doesn't always come out as well. I see that Aria has put her own lines on her graph. No, that's opposed to a horizontal stretch. We've talked vertical. Now we're going to talk horizontal. Just as how when we're doing translations, and we talked about how you do something to the x before the operation, and that gives you horizontal. It's the same thing with stretches horizontally. So here's an example of an original function being the square root of x. Before we take the square root of x, we multiply that x by 2. Or we multiply that x by 1/2. Those are not going to cause you to have vertical anything. Those are going to be horizontal. Right? They're going to affect the horizontal axis this time. So what I've done is I've given you a square root diagram, a square root table of values, sorry. And go ahead and put on your square root function right now before we do the transformations. Right? These are your square root values right here. 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. We know those. Right? We've seen those before. Draw me that square root line right now, please. Go ahead. On your graph, draw me that square root line. And I apologize that the lines are not clear on yours, but just give me your best line. All right? At least the numbers are there, I think. The numbers are there, aren't they? Yeah, the numbers are there. So give it your best judgment. Draw me a square root line. So I'm going to go ahead and do that myself. I have the advantage of being able to see my grid a little bit better than you, a lot better than you. 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. Okay, so there's my square root line, square root of x line. Now, remember I also told you yesterday that horizontal is always backwards. It's kind of the opposite of what you expect. When you put a minus with your x, it goes to the right. When you put a plus with the x, it goes to the left, and you're thinking, isn't that kind of the other way around? Well, horizontal is kind of backward. So if I put a 2 beside the x, first of all, my question is, am I going to be affecting my x values or my y values? If we're told it's horizontal, should I be expecting it to affect my x values or my y values? That's the question. Let me go in the back room and ask Charmaine, what do you think? It does affect the x. Does anybody want to hazard a guess as to how it affects the x, though? What's going to happen to each of the x's if I multiply by 2 first? Yes. You divide by 2. That's exactly right. You divide by 2. Each x gets divided by 2. As surprising as that sounds, that's exactly what happens. So here's what the transformation is. You have, if you're dividing by 2, making it smaller, you have a horizontal compression by a factor of a half. Because you're multiplying by a half or dividing by 2. Because you divide by 2 and multiply by half, it's the same thing. Right? So the factor that you're going to use this time is a half. Right? You're going to multiply each of your, and you said it right. Between you both, you said it right. It's the x values that get changed. Your y values are not changing, but this is horizontal. Your horizontal anything affects your x's, not your y's. I can go ahead and put all my y's back right now. 0, 1, 2, 3, and 4. Those are not going anywhere. Those are the same. But now, each of my x values get chopped in half. So 0 is still 0. Half of 0 is still 0. Half of 1, though, is a half. I put 0.5. Half of 4, of course, is 2. Half of 9 is 4.5. And half of 16 is 8. Every single x value was compressed by a half or multiplied by a half. Same thing. So let's see if we can, again, I know you don't have as good a grid as I do. Yes.
Why would it be by a factor of a half?
Because we always take 1 over whatever that number is that you multiply your x by. It's always 1 over that number. And it says it in the thing above here, or multiplied by 1 over k. It says the variable is x is divided by or multiplied by 1 over. Okay, you're welcome. So, and thank you for the question, by the way. Let me change colors now. 0, 0 is still on the graph. 0.51, 0.51 is somewhere around here. 2 is 2. It's going to be kind of hard to see it. It's almost looks like they're in the same place. 4.5 is 3. 4.5 is 3, which is about here. And 8 is 4. 8 is 4, somewhere around here. It almost looks as if you're pulling it. It's almost as if you're pulling it this way, right? You're compressing it along the x-axis. My arrows are in there, Che. Don't say anything. My arrows are there. Right? So it looks like it's like pulling it this way along the x-axis. Right? If you are stretching it, well, we're going to find what happens when we stretch it. It might be a little different look to it. So, who thinks they can tell me what is happening, what kind of transformation is taking place here. Before we square root it, we multiply each x by a half. Is your hand up? No? You sure your hand isn't up, right? Okay, all right, hand isn't up. Sana, what do you think? By a factor of, you came so close, but the last part of the end was the part I wasn't happy about. By a factor of 2. If it's a stretch, it means that the number that you should have should be a number bigger than 1. So it's a horizontal stretch by a factor of 2. By taking this half and flipping it upside down. Because it's always 1 over, where is it? Multiplied by 1 over k. And if you take 1 half and you invert it, it becomes 2 over 1. So it's now 2. So it's a horizontal stretch by a factor of 2. I put that in purple. Horizontal stretch HS BAFO 2. So how do you think my table is going to look now? Help me out now. What's going to happen in my table? What happens to my x's? What happens to my y's? Help me out here, folks. Help me out. Come on. I want to see some participation, especially up in the front of the room here. What happens to my x's? What happens to my y's? Go ahead, Ron. X is going to be divided by 0.5. Okay, another way of saying divided by 0.5 is what? Multiplied by 2, exactly. All my x's get multiplied by 2. We're going to do it again. Go back to the original right here. That's what we're going to be multiplying by 2. Not these guys. These x's get multiplied by 2. So I'm going to have 0, 2, 8, 18, and 32. We might not be able to put that last one on there. Or should we maybe be able to put it on there? How about my y's? What is going on with my y's, folks? What's going on with the y's? People in the front here need some participation. What's happening with the y's? Yes, Abdullah. What's that? They stay the same. Exactly. So my y's are still 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So I'm ready to draw my graph now. Here comes my graph. I'm going to come around and have a look at yours in a minute. 0, 0, they all seem to have that as an invariant point. And then 2, 1. 2, 1 should be about here. And then 8, 2 should be about here. Even that the shape of this doesn't surprise anybody. 18, 3. 18, 3 should be about here. And 32, 2. 32, 2 should be about, 32, 4, sorry. 32, 4 should be about here. So it almost looks as if you are pulling it along the x-axis, right? Stretching it along the x-axis. That's what the language says. It's a horizontal stretch by a factor of 2. Okay? And these are the coordinates that would represent that. Invariant points in all cases was 0, 0 for this one. And it was the same thing for up here. The invariant point here was 0, 0. That never changed in any one of them. Because you multiply 0 by anything, it's still 0. Right? Okay. So you can get another page in. I'll give you some time to start the homework today. I usually sort of just teach right all the way to the end, but I'd like to give you a chance to get started on the Desmos assignment. So if there are any questions, you can ask me before you go. All right, but let's see if we can get another page in. So here's a summary table, right, which you can go through and on your own time. Let me go down to these two down here, right? Go through the summary stuff later on. Determine 2 equations for each of the following and label the graphs. Now let me just say this. It is possible when you're dealing with these vertical and horizontal stretches that you could make the case for a horizontal stretch being represented by a vertical either stretch or compression. It is possible. And that's what we're going to see when we try to write equations for these 2 graphs here. Okay, so I'm going to walk you through this. Let's start off with the A graph. What do you think is the base function for the A graph? Help me out, folks. I got to get some more participation, especially in the front of the room. Thuzan, what's the base function for the A graph? We just did one just like it. It's a square root function. Thank you very much. So here's what we're going to do. We're going to first of all come up with some points. And by the way, this matches with our square root function. 1 is 1, 4 is 2, 9 is 3, and so on, right? So it matches the square root function. Now, let me grab my stylus here. So let's take one of those points. Let's take the point 1, 1, right? Where does it seem like that point has gone? Tell me where you think that point has gone. Aria, go ahead.
The first line at the bottom.
Okay. Which is what? Give me the point. Give me the coordinates. Well, that's 1, 1. No, this one right here, that's 1, 1. Where do you think that has gone? How far do you think it has gone? Where do you think that, what's the image of that point?
2 up.
2 up? I think you're thinking about translations right now, but we're thinking about stretches and compressions. You had your hand up earlier on, Aaron. Where do you think that point has gone? 1, 3. I can see 1, 3 on there. It looks, where is it? 1. Sorry, 1, 3. 1, 3 seems to be one of the points that's on there. Do you see?
Wouldn't that be 2 up then? Right
yeah, but you're thinking about a translation. Right now we're multiplying the points. We're not adding on or subtracting. So you're thinking more translation, but I'm thinking more of a stretch. So that point seems to have gone to the point 1, 3. Can we agree on that, first of all? Does that point make sense? You can see that point on the graph, right? You should be able to see it on your own graph. Chair, are you following along here? What are we doing here? Oh, sorry. I keep thinking that you're doing something with your phone. All right. Phones and calculators sometimes can't tell them apart. All right. Good. Can we agree that 1, 3 is on this graph? Can you agree on that back here, Masumi? Okay. So if 1, 3 is on this graph, does this look like it could be a vertical or a horizontal? And is it a stretch or is it a compression? That's the question I need to ask you, right? So it looks like the 1 is still a 1, but the y value became a 3, is what it sounds like is happening here, right? Okay. So my question now is, if that happened, what do you suspect is the kind of transformation that took place here? Go ahead, please, Atiba. By a factor of, thank you very much. Vs by a factor of 3. Let me put the 3 under it because it looks like I'm saying 0, 3 here. BAFO 3 by a factor of 3. Okay. Okay. Yes. We get into horizontal stuff in a second. Because remember, we could make the argument for horizontal, so just hang on to that just a minute, please. Excuse me. Okay. So if that is the case, can somebody suggest the base function, that we got this from Methuselah earlier on, the base function is the square root of x, right? So what are we saying? If there's a vertical stretch by a factor of 3, what would you suggest is the equation that would generate the line that we're looking at right now? Think about how we'd write that. Okay? All right, let me hear from Jahim at the back. Thanks for offering. Go ahead, Jahim. I wasn't thinking of that. What were you going to say?
Y equals square root 3x.
Square root 3x. Wasn't thinking of that either. Yes.
So 1 and 3 is outside the square root?
3 is outside the square root because it's a vertical stretch is what we're talking about. And a vertical stretch means you take the square root first and then you multiply by the factor. What you're talking about is horizontal, and it will be a compression as a matter of fact. So here's what we're saying. That would be, so the equation of this line, possible equation, would be y equals, or f of x equals 3 square root of x. Okay, that would be the vertical stretch possibility. Now, let's look again at the graph and ask ourselves, is there something else that could have happened here? And let me give you an idea. Let me give you an idea of what I mean by something else that could have happened here. I want you to compare, I'm going to circle something here. I want you to compare this point with this point right here. I want you to look at those 2 points. Can we agree that those 2 points look like they could be maybe possibly related? Right? There are 2 points that are easy to read on the graph, right? Can we agree on that? And I chose 2 points that were along the same, and this is the clue to it, that were along the same y line. Both along the same y line. Which means I'm moving horizontally, basically. Okay? So this point here is the point 1, what's that? 1, 3. That's the image point. So that's the point 1, 3. What was the point that was on the original graph? Look at this graph right here. Right? Where did that point go? What was the original point that gave us that 1, 3? Go ahead. 9, 3. So it looks like 9, 3 ended up being 1, 3. Right? So 9, 3 became 1, 3. Right? I'm just showing it to you. You can see both of them are on on the 2 lines. This is clearly 1, 3 right there, right? This is clearly, hopefully it's clear. This is clearly, do you have the grid on yours? Can you see the grid on yours? You can, okay. 9, 3. So if that was the case, if we looked at it that way, would this be a vertical or a horizontal? And what is actually happening if it was either one? Is it horizontal or is it vertical? Yes. It's a horizontal. We go back. It's a horizontal. You went from 9 to 1. 3 stays the same. And you're saying it's a stretch? I don't think it's a stretch. I don't think it's a stretch though. So I agree with horizontal, which is why my x's are changing. Went from 9 to 1. In what way? Can anybody, Aaron, go ahead. Sorry? It's a horizontal compression by a factor of what? What did I multiply by to go from this to that? Yes. 1 over 9. There you go. It's a horizontal compression by a factor of 1 over 9. So let me write that down. So this is one possible equation. So I'm going to say this would be a horizontal compression by a factor of 1 over 9. 1 over 9 is 19 for some reason. Sorry. Now, can we find a way to write this as an equation is the question. Instead of writing it as a description, words, can I write that now as a y equals equation? Can anybody give that to me as a y equals equation? Che, go. There you go. And something tells me Atifa is going to tell me the same thing. This 1 over 9, that makes it have an a value of 9. You flip it over. You all flip it over. Now we can see, oh, hold on. Square root of 9x. Wouldn't that be, and by the way, that's by a factor of 1 over 9. Wouldn't that be the same thing as the square root of 9 times the square root of x? Isn't that the same thing as 3x? That's why they're the same. That's why they look the same, I should say. Let me change that. That is why they look the same. Because this equation here is what we said the equation was up here. But now we can rewrite it as the square root of 9x to make it a horizontal compression rather than as a vertical stretch. So I said sometimes a vertical stretch can be written as a horizontal compression. It's possible. Okay? Because it really is the same equation. Take out the headphone from me, please. All right? Did that make sense, Amira? Okay. Sarah, how about you? Does that make sense? Or do you need to go over that again? They're both the same equation, but interpreted in different ways, leading to the same result. And we can take any other point on this line and see if we could come up with something similar. We're going to try this again, and then we'll stop. It's now 12:08. I'm going to erase all of this because I need to give myself some room for these graphs over here. We're going to try the same thing again. We're going to see if possibly we could write it in two different ways. I'm going to try that. Maybe as a horizontal or vertical compression or stretch. Let's see if this works. All right, here we go. So as I said, I need some room. Actually, what I could do is just copy this onto another page. I'll do that instead. Let me copy this whole thing onto another page. All right, that wasn't the best copying, but anyway, we'll make the best of it. Okay, let's look at this now. So my first question is, of all the different types of functions that we've been looking at, I'm going to go to Naomi on this one. Which kind is this? What does it look like is the base function? Look at all the functions that you have just above there. One of them is represented by this. Which of them? So we have, can I just borrow this a second, please? Linear, quadratic, square root, cubic, reciprocal, absolute, exponential. Which one of them do you think this is? The base function. Absolute value, good. Absolute value, all right. So that's y equals absolute value of x. That's my original function, right? That's what that is. Okay. Let me show you an easy way to figure out what might be going on here. Let's see if we can figure an easy way to it. If this was, let me start off with vertical. This was a vertical anything. By the way, which one of these is the original? Is it the slimmer one or the flatter one? Which one is the original? Yes, Atifa. The slimmer one, you're thinking? It's actually the flatter one. If you think about it, 1 and 1, 2 and 2, or sorry, 1 and 1, 2, 2, 3, 3. Y equals x. It's all the x's are the same as the y's, but they're all positive. So it's really the flatter one that is the original. Okay? Okay. Hold on, please. Hold on. So the flatter one is the original. And I'm going to try to see if I can match up some points now. And let me give you a clue. I'm going to make this the vertical either stretch or compression first. All right? For me to get this vertically, I'm going to see if I can find a vertical line that matches up. So for instance, let's see if anybody else can see what I'm seeing here. Let's take this point here and say it looks like it ended up at this point right here. That's what it looks like to me when I go along that vertical line. Does that kind of square with what you think? Do you see it the way I see it? Right? If I'm going vertically, up like that, along the same line at 2, right? It looks like the other point that matches up to that one is this point up here. Masumi, do you see what I'm saying on that? Does that make sense? Okay, so Masumi, give me those 2 coordinates, please. Give me the original on the original line, then give me the image point, and let's see if we can figure out what's going on there. So give me the original point, and then we're going to write the image point after that. All right, so what's the original point? What's that? Okay, I can make that bigger for you. Can you see that now? Okay, so what's the original point that I picked off there? What's that? What are the coordinates? 2 and 2. Okay. And then what are the coordinates of the new point that I got from that, which is along the same vertical line? 2 and 8. Okay. Can we all agree on that, first of all, before we do any further? Okay. Amira, so talk to me now. What do you think is happening? They're both along the same vertical line. What do you think is happening in terms of, and I'm going to make it a little easier for you by saying it's going to be something vertical. And therefore, it's either a stretch or it's a compression. And there's some factor that I'm trying to figure out here. What do you think? Good. By a factor of? Excellent. Yes, by a factor of 4. BAFO, 4. VS, BAFO, 4. Is there anybody who disagrees with that or is not sure where that came from? The 2 remains the same as 2. Didn't do anything to the 2. The other 2, which is a y, got multiplied by 4, which is why it's now 8. So what's the equation that would generate this function? Go ahead, please. Yeah. Would be outside of the absolute value. Yeah. So y is equal to 4 absolute value of x. That is what would generate that function right there. 4 absolute value of x. Now, that's one version of the answer. The other version of the answer is to see if maybe we can come up with something that would be horizontal. And for me to do that, I'm going to try to find 2 points that are on the same horizontal line. Let's see if we can do that together. All right? So I'm going to go up here now. I'm thinking maybe, I don't know, this point, I'll use a different color. I'm thinking this point right here seems to have ended up right here, going horizontal. Would you agree with me on that, by the way? That somehow this point here is the same as that along the same vertical, same horizontal line. Now remember now, the original point is this point right here, and that point ended up here. Okay? So, my original point, let me see if I can get some help on this. Angelique, can you give me the original point that came from the original line? One of those red dots came from the original. Okay? From the original graph. Can you tell me? Is it the slim one or the flat one? The flat one. Okay, so tell me what point is coming from the original then. Four and 4. Okay? So originally, it was 4 and 4, and somehow it ended up over here. So my question now is, thanks for offering. So my question now is for Jasmitha, is what are the coordinates of the new point? And then tell me after that, what do you think is happening here? 1 and 4, okay. So what do you think is happening? How do I go from 4, 4 to 1, 4? What kind of transformation are we looking at for that? No, I'm going to have to disagree with you. I want you to rethink that. I'm going to have to rethink that. I'm going along the same, what kind of line is this? What kind of line is this? Ah, that's your clue. That's your clue right there. You said it was vertical, but you know it's not vertical because it's all along the same horizontal line, right? Okay, so fix it. Horizontal compression. I'm going to ask somebody else for the factor in a minute. I'm going to write that down. HC. HC BAFO. Okay. Now comes the tough part. Rosie, can you help me out, please? What is the factor this time? By a factor of, it's not 4. It's not 4. It is not 4. Shay, 1 over 4. What you're multiplying by, what you're doing to make the 4 become a 1 is multiplying it by 1 over 4. Do you see what we're saying here? So that's your BAF, that's your horizontal. And it's a compression anyway, so compressions need to be less than 1. Okay? Okay, the question now is, what is the equation? Go ahead, Sarah. Sorry, say it again. The 4 inside of the absolute value, I absolutely agree. So y is equal to 4x, like that. So it's an absolute value, and it's not 1 over 4, it's now 4, because it's always the inverse, it's always the reciprocal of whatever the factor is. This gives you a horizontal compression by a factor of 1/4. Okay, I'm going to stop there.